Good morning and welcome back to your final exam review for college algebra. We left off with problem 8 and we will pick up there today. And I want to give a shout out to Nick Bashir because he is smiling right now and it's always good to have a happy face in class. Okay, here we go. Solve the following radical equation. So we've got a radical equation here. Our goal is first to isolate our radical, then solve. And I want to remind you before we start that when we solve a radical equation, it is always possible to introduce extraneous solutions. So we do have to check our answers that we get and make sure that they really do solve the problem. So we're going to go through the math, we're going to get some answers, but then we have to check our answers to make sure that they work. Okay, so that's a thing that sometimes people forget. It says here, please enter your answers beginning with the first answer box. Note, both boxes might not be used. So we're probably going to get 2 answers since there's 2 answer boxes here, but we do have to check them and make sure that they actually solve the problem. Okay, so let's go. We're going to begin by getting our fancy pen. Okay, I'm going to subtract an 8 on both sides to isolate this radical. So that leaves me with, move it over here, radical 3y plus 37 is equal to y minus 1. Okay, so now we need to undo a square root. To undo a square root, the opposite of taking a square root is squaring. So we will square both sides of the equation. Alright, so when I square the first side, squaring cancels square root. That leaves me with 3y plus 37. Squaring the second side, y minus 1 quantity squared, I'm going to FOIL with itself. That gives me y squared minus 2y plus 1. It's the result of FOIL. Now, I notice this is quadratic. So in order to solve a quadratic equation, I'm going to try to set this thing equal to 0. So I will subtract 3y, and I will subtract 37 from both sides so that I can set it equal to 0. I'm choosing to empty the left side since the y squared is positive on the right. I prefer to keep it positive. So I'm going to subtract 3y and subtract 37. So that leaves me with y squared minus 5y minus 36. Okay, now we may consider, does this quadratic expression factor? Are there factors of negative 36 that would give me a sum when added of negative 5? Negative 9 and 4. So if I multiply negative 9 and 4, I get negative 36, but when I add, that gives me negative 5. So then this factors, I don't know why it's doing that. Okay, try again, change colors. To y minus 9 times y plus 4. And then, according to the zero product property, each of those could be set equal to 0 to solve. So that gives me a solution of 9 and negative 4. But remember, when we solve a radical equation, we have possible solutions because when I square both sides of an equation, I could have introduced an extraneous solution. So I do have to go back and check positive 9 and negative 4 as solutions. So to do that, I will substitute radical 3 times 9 plus 37 plus 8 equals 9 plus 7. Does each side of this equation equal each other? So 3 times 9 is 27, and 27 plus 37 is 64, and the square root of 64 is 8 plus 8. And 9 plus 7 is 16, and 8 plus 8 is also 16. So 9 gave us a good solution. 9 is a good solution. Okay? Now we will check to see if -4 is a good solution. So, checking the -4, we'll do the square root of 3 times -4 plus 37 plus 8 equals -4 plus 7. So on the right side, we're going to get 3. Question is, does the left side simplify to equal 3? Well, 3 times -4 is -12, and -12 plus 37, 25, and square root of 25 is 5. Is that right? So I'm going to add 5 plus 8, which is 12, or 13. That does not equal 3. 13 does not equal 3. So -4 is an extraneous solution. That is not a true solution. So on this particular question, you would only use one box and leave the second box blank. Okay? That's not going to happen every time. It is possible that they both work. Okay. Next question. Okay, this is the next question. This is the distance that an object falls from rest when air resistance is negligible varies directly as the square of the time that it falls before it hits the ground. A stone dropped from rest travels 175 feet in the first 4 seconds. How far will it have fallen at the end of 5 seconds? Round off your answer to the nearest integer. This is a direct variation question, and we learned that with direct and inverse variation, it's really a 3-step process. Step 1, create the formula. Write the formula. Okay, so that is described in the very first sentence. The distance that an object falls from rest when air resistance is negligible varies directly. So distance varies directly. Directly is going to mean k times something. Inversely is going to mean k divided by something. Okay? Distance varies directly. So k times as the square of the time. So that's t squared. Okay, so step 1, write a formula. Step 2, substitute in numbers and solve for k. So they give us some example numbers. We're going to find out what does k, the constant of variation, equal. A stone dropped from rest travels 175 feet. There's your distance. In the first 4 seconds. So I've substituted the given information, and I'm going to use that information to solve for k. I know that 4 squared is 16. So divide by 16. K is, I'm just going to use the fraction, 175 over 16. Remember that k is a number that you do not ever want to round. Okay, you're just in step 2. It says at the end to round off your answer to the nearest integer. That is not talking about k. K is not the answer. K is on the way to the answer. Do not round to k. All right, step 3. Now that we know what k is, solve the question or answer the question that was posed at the end. So how far will it have fallen? That's talking about distance. What will the distance be at the end of 5 seconds? Well, k is 175 over 16, and we're multiplying by the time, 5 seconds squared. So you should be able to input all of that in the calculator and then round to the nearest integer. So I got 4375 over 16, which as a decimal rounds to 273. It's 0.4, so it's to the nearest integer. I'll say 273 feet. 273. Okay, so the next question says to solve the following nonlinear system algebraically, and be sure to check for non-real solutions. So this is nonlinear because we have higher powers. We do not have all first powers. but we can use a lot of the same ideas of solving linear systems of equations here. We're just going to have more solutions. So in looking at this, I noticed that both of these are in standard form. X squared plus y squared equals the constant. I'm going to use the elimination method here. So I'm going to decide, do I want to eliminate x or do I want to eliminate y? Since this is positive and this one's negative, I think I'm going to multiply that top equation by 3. And that's going to allow me to eliminate the y's. Okay? So I'm rewriting the top equation. 3 times x, or x squared is 3x squared. 3 times y squared is 3y squared. 3 times 32 is 96. Second equation, I haven't changed. Bring it down. 2x squared minus 3y squared equals negative 16. In elimination, we add the two equations together, and our y squared terms are going to cancel. So 3x squared and 2x squared adds to be 5x squared, and 96 minus 16 is 80. Next, we're going to divide by 5. So x squared equals 80 divided by 5 is 16. Thank you. And then we take the square root of both sides. And x would equal, remember when you take square roots, you're going to get plus or minus. This is where the mistakes happen here. Square root of 16 is plus or minus 4. So, in finding our solutions, we have to substitute positive 4 and negative 4 for x coordinates. Okay? So let's find solutions if I substitute a positive 4 for x. Now, I can go back to either original equation, but clearly one of them is going to be easier to work with than the other, so I'm going to work with the first equation. So if I substitute a positive 4 for x, that would be 4 squared plus y squared equals 32. 4 squared is 16. And subtracting 16 from both sides, I get that y squared is equal to 16. And then I take the square root, and I get y equals plus or minus 4. Now, that was when I substituted positive 4. I get 4 or negative 4. So these are two possible solutions that have introduced themselves when I substituted in positive 4. I got plus or minus 4 for y. Then I have to consider the possible solutions I get if I substitute negative 4 for y. So if I were to substitute if I substitute negative 4 for x. If I substitute negative 4 for x, I want you to notice what happens here. Negative 4 squared is still going to be 16. I'm still going to subtract 16 on both sides. I'm still going to be taking the square root of both sides. I'm still going to get plus or minus 4. So, negative 4, 4, and negative 4, negative 4 are also solutions. So this gives me 4 solutions. I got 4, 4, I got 4, negative 4, I got negative 4, 4, and negative 4, negative 4. 4 solutions here. Okay, this next problem says to solve the rational equation. If needed, submit your answer as a fraction, reduced to lowest terms. So we have a rational equation. What we want to see when we're solving a rational equation, I would love to see a single fraction equals a single fraction. Okay? So looking at the left side of the equation here, I hope you notice that there's two fractions. So what I need to do is combine them, subtract them, so that there's only one fraction on the left-hand side of the equation. But in order to subtract, we have to have what? Common denominator. Yes. So to create a common denominator, I'm going to have to do some multiplication. The first part is going to have to be multiplied by what binomial? y minus 5. So we're going to multiply by y minus 5 over y minus 5. The second part is going to have to be multiplied by what binomial? 2y plus 1. So we're going to multiply that one by 2y plus 1 over 2y plus 1. Okay, so now it's time to do the grunt work. Okay, on the first set of fractions here in the red, we're going to take the 4, the numerator, and distribute it to our y minus 5. So that gives me 4y minus 20 over, I am not going to multiply out the denominator at this point. 2y plus 1 times y minus 5. This is a subtraction problem. And looking at the green part, I'm going to take the y and distribute it to 2y plus 1. So I'm going to get y squared, sorry, not y, 2y, 2y squared, and y times 1 is plus y. All over 2y plus 1 times y minus 5. Please notice here that we have a common denominator in both of these larger fractions. That means that I'm allowed to subtract the numerators. Okay, if the denominators match, I'm allowed to subtract the numerators. So subtracting the numerators, I'm going to distribute the negative in. So that becomes plus a negative 2y squared and a negative y. Now, looking at those numerators, let's put those terms in descending order. So I'm going to get negative 2y squared. I'm going to combine 4y plus negative 1y to get 3y. And that is a minus 20. That is all over the single denominator, 2y plus 1 times y minus 5. Let's FOIL that out now. 2y times y is 2y squared. 2y times negative 5 is negative 10y. 1 times y is 1y. And 1 times negative 5 is negative 5. The negative 10y and the positive 1y will combine to become negative 9y. Now check that out with the other side. If, see if I can grab all of this. Nope, nope. Okay, there we go. That's all I'm recording. Isn't that good? Okay, so that is equal to negative 3y squared plus 3y plus 44 all over 2y squared minus 9y minus 5. Now, we've got a single fraction equal to a single fraction. That's the first thing I said. I would like to see this as a single fraction equal to a single fraction. Well, since we have matching denominators, and this is said to be equal, if the denominators are equal, then the numerators also have to be equal. So since the denominators match perfectly, I don't have to work with them anymore. Now I can just set the numerators equal and solve. So we have negative 2y squared plus 3y minus 20 is equal to negative 3y squared plus 3y plus 44. I've got y squared on both sides. I would like to eliminate it on one side. So I'm going to add 3y squared to both sides. I have y's on both sides, so I'm going to subtract this 3y. I'm going to do those 2 steps and see where that leaves me, okay? So, negative 2y squared plus 3y squared is y squared. The y's cancel. That cancels, that cancels. But it's a lot prettier. Okay, I could, at this point, add 20 to both sides and take the square root, or I could subtract 44 from both sides and factor. It doesn't matter. Okay, I'm going to add 20 and take the square root. So adding 20 to both sides, I get y squared is equal to 64. And taking the square root of 64 is plus or minus 8. Plus or minus 8. We also have to consider that our denominators cannot be 0. When we're solving a rational equation, we have to consider both answers, 8 and negative 8, and consider, do either of those, if I substitute them in the original problem, make a 0 in a denominator. So going back to consider that, if I substitute in 8 or negative 8 here, I'm fine. 8 and negative 8 here, I'm fine. 8 and negative 8 here, I'm fine. As long as no zeros occur in the denominator, then you can keep both answers. But it is possible to get, for example, if I had gone 5 for a solution, if 5 had been a solution, because of this right here, 5 minus 5 would make a 0, I would have to discard 5 as extraneous. Okay? So 8 and negative 8 should be fine. 8 and negative 8. Next question. For the above function, determine f of x plus a minus f of x. So we're going to break this into 2 parts. We're first going to evaluate what is f of x plus a, and then we're going to subtract f of x from it. So step 1, let's evaluate f of x plus a. So f of x plus a means to replace x in the original function with the quantity x plus a. So f of x plus a is going to be replacing x with x plus a minus 10. That is it. F of x plus a is square root of x plus a minus 10. The second part of the problem is to subtract the original function from that answer. Okay? So here is that answer, the square root of x plus a minus 10. And I'm supposed to subtract from that the original function. The original function was square root of x minus 10. This is it. There is nothing that simplifies. There are no like terms anywhere. That's the answer that you submit. It's easy. Okay, this next question tells me that the half-life of hydrogen-3 is approximately 12.3 years. I need to know that. This is a time. Okay, then it gives me a formula down here. Determine little a so that a of t, or the amount after time, equals the initial amount times little a raised to the t power. That's describing the amount of hydrogen-3 left after t years, where a sub 0 is the amount of time at time 0, or the initial amount. And we're going to round little a to 6 decimal places. Okay, so we're going to start with this formula. A of t equals a sub 0 times little a to the t. And this is weird because the only number they really gave us was time. The time it gave us was 12.3.
We need all juniors who is turning their permission slip to either Ms. Collins or Ms. Birchfield to come on down to this common area.
So the time is 12.3. The initial amount and the amount after time, you got to think about what are they describing here. They're describing a half-life. So if you're starting with, say, I don't know, 50 of whatever this is, then the amount after 12.3 years would be half of that initial amount. So that amount after 12.3 years would have to be 25. It's halving it. So I could put any numbers here, 150, or 2 and 1. Okay, now, to solve this, we're going to divide by 50. And every single time on the left side, we're going to get 0.5 equals a to the 12.3. How do I solve for little a? I'm going to take the 12.3 root of 1/2. 12.3 root cancels 12.3 power. So little a equals, take the 12.3 root, 12.3 root of 0.5. I said round little a to 6 decimal places. So I got 0.945205. There's your answer for this part. Okay, so now this is the next part of the question. It says, how much of a 15-gram sample of hydrogen-3 would remain after 7 years, round to 3 decimal places? So now we're talking about an initial amount of 15 grams. So the amount after 7 years, where your starting amount is 15 grams, and little a was already determined to be 0.945205. We want to know, after a time period of 7 years, how much of this 15-gram sample would be left. All we have to do is input this to the calculator and round to 3 decimal places. So I got that the amount after 7 years would be 10.1105, so 0.111 if I round to 3 decimal places. Okay, the next part of the question says how much of a 15-gram sample of hydrogen-3 would remain after 9 years, round to 3 decimal places. So again, we're talking about an initial amount of 15, where little a is 0.945205, and it's asking about the amount after 9 years. So the amount after 9 years, we're just going to input this into the calculator and round to 3 decimal places. So I got the amount after 9 years would be 9.03. It says 28, so I'm going to say 033. Okay, in this problem, we are told to determine the implied domain of the given function and express an answer in interval notation. So implied domain, we need to remember our red flag situations. Red flag number 1 would be an x in a denominator. Red flag number 2 would be an x under an even root. The double red flag situation is where we have an x in a denominator that's also under an even root. Okay? So those are our 3 restrictions on domain. When you have an x in the denominator, you would say that the denominator cannot equal 0, because we can't divide by 0. When you have x under an even root, you would have to say that the part under the root, the radicand, has to be greater than or equal to 0, because you can't take the even root of a negative. When you have both occurring, then it can't be 0, and also it has to be positive, so you would have to say x is greater than 0. It could not equal 0 in that case. So those are your 3 red flag situations. So what red flag do we have here? We have an x under an even root. So in that case, you take the whole radicand, x plus 1, and say that it has to be greater than or equal to 0. So solving that, I get x is greater than or equal to -1. Everything greater than or equal to -1. And if you struggle with interval notation, I do recommend number lines to understand it. Greater than or equal to -1 would be at -1. We equal it and we go to the right. So the interval notation would be square bracket -1 to positive infinity. Okay, in this problem it says to solve the logarithmic equation and round your answer to 4 decimal places. When we're solving a log equation, our first step is to combine so that we write this as a single log expression. So we're going to use our properties to write this as a single log expression. So looking here, since I have addition, I can use the product property and rewrite this as log base 5 of the product x minus 1 times x minus 2 is equal to 3. Next, let's FOIL these binomials. So I'm going to write this as log base 5 of x squared minus 3x plus 2 equals 3. After you write this so that it has a single log expression, you have one of two possibilities when you're solving a log equation. You could either have log on both sides of the equation or log on one side of the equation. If you got log on both sides, you're basically trying to make both sides match. If you have a log only on one side, as we have here, you're going to convert it to the exponential form. So changing forms now, I'm going to write this as 5 raised to the third power equals x squared minus 3x plus 2. And I'm solving a quadratic equation now. So what is 5 to the third power?
125. Yeah, 125.
125. Equals x squared minus 3x plus 2. Next, we've got a quadratic equation to solve. We're going to subtract 125. Sorry. I don't know why that happens. I'm going to subtract 125 from both sides. So 0 is equal to x squared minus 3x minus 123. Is that right? Okay, did this say to round? It says round to 4 decimal places. So, yay, I get to use the quadratic formula here. It's going to be a decimal. Okay, so now I'm going to use the quadratic formula and say x equals negative b, that's going to be negative 3, or 3, plus or minus radical b squared, that's going to be negative 3 squared, or 9, minus 4 times a times c, all over 2 times 1 is 2. So I'm going to evaluate the radicands here, which is the discriminant. 9 minus 4 times 1 times negative 123. 501. 3 plus or minus radical 501 over 2. So I'm going to do 3 plus the square root of 501 over 2. And I get, hold on a second, the mode, what I said. Okay, 3 plus the square root of 501 over 2, which as a decimal is 12 point, how many places did it say to round to? 4. So 12.6915. And then I will do 3 minus the square root of 501 divided by 2. And I got negative 9.6915. When you're solving a log equation, you have to consider the fact that we can't take the log of a negative number. So you do have to consider your solutions and consider, do either of those solutions make me take the log of a negative number? So if I substitute in the positive 12.69, 12 minus 1 is still positive, 12 minus 2 is still positive. But if I substitute in a negative 9.69, negative 9 minus 1 is going to be further in the negative. So that's going to mean I'm taking the log of a negative. So the negative answer here has to be rejected as extraneous. You only have one solution, 12.6915.